In 2003, automotive engineering was a discipline of thermodynamics and metallurgy. The industry's mastery lived on the assembly line, where thousands of precision-tooled steel parts were synchronized into a single machine. Every component flowed through the Tier 1 supplier ecosystem. This was a closed network of legacy manufacturers that dictated which innovations reached the road, ensuring that every new feature fit within Detroit's existing manufacturing logic. To the engineers in these boardrooms, artificial intelligence was a niche branch of computer science. It was a subject for university labs, not a tool that could navigate a 2-ton vehicle through a construction zone. The engineering goals were strictly mechanical. Success was measured in horsepower, fuel efficiency, and the structural integrity of the passenger cabin. Because intelligence wasn't considered a necessary component of the vehicle, the traditional industry remained focused on hardware, while the requirements for driving were beginning to shift toward software. DARPA, the Pentagon's research arm, moved the testing ground to the Mojave Desert. They traded the controlled environment of a factory for 142 miles of sun-bleached dirt and unpredictable terrain. The March 2004 Grand Challenge offered a $1 million prize for any vehicle that could navigate the course entirely on its own. There were no drivers, no remote controls, and no paved roads. The competitors weren't traditional automotive engineers. They were roboticists who bolted arrays of lasers and cameras onto modified chassis, like Carnegie Mellon's Sandstorm, to try and turn a mechanical object into an intelligent one. Not a single vehicle finished the race. Sandstorm traveled the furthest, but it managed only 7.4 miles before getting stuck on a rock and spinning its tires into the dirt. The public saw 15 vehicles fail and concluded the technology was decades away. But for the teams involved, those 7 miles provided a baseline of real-world data that had never existed before. DARPA reset the challenge just 18 months later. The short interval forced teams to abandon slow, incremental development in favor of rapid software iteration. In the 2005 race, 5 vehicles completed the entire course. The Stanford team took first place, finishing in under 7 hours, and proving that autonomous driving was an engineering problem with a clear solution. By 2007, the challenge moved into the city. Vehicles like Carnegie Mellon's Boss were forced to obey traffic laws, navigate intersections, and interact with other cars, proving the tech could handle real-world complexity. By forcing these teams to compete in public, DARPA achieved what traditional R&D cycles couldn't. They compressed 30 years of progress into a single 3-year window of development. Traditional automakers viewed these results as experimental. The technology was being developed outside Detroit, using sensors and software that didn't exist in their established supply chains. This created a parallel talent economy. The engineering breakthroughs weren't happening in Michigan. They were concentrating in a new network of tech companies that were being built around the DARPA participants. The winning leaders moved directly into the tech sector. Sebastian Thrun, who led the Stanford team, founded Google's self-driving project, taking the technical foundation from the desert straight to Silicon Valley. Chris Urmson from Carnegie Mellon followed a similar path, serving as the CTO of the Google project before founding Aurora. This wasn't limited to a few leaders. The DARPA challenges created the core workforce for the entire autonomous industry, as the engineers who built these racing machines went on to join or found virtually every self-driving startup in existence. While Detroit remained focused on perfecting the mechanical assembly of cars, the specialized labor pool required to make those cars intelligent was consolidating in Northern California. This shift created an existential tension. These newly formed tech teams weren't just running experiments. They were building the software layer that would eventually control the physical hardware Detroit manufactured. Because the breakthroughs happened outside the traditional automotive ecosystem, the industry lost its grip on the technology that would define its future. The race in the desert had effectively moved the center of gravity for the car from Michigan to California.